MPL is a national measurement institute, so we develop and realize primary methods of realizing the units of measure for different physical quantities, mass, length, time, and also, in my case, acoustics. And so a lot of our research goes into developing new methods of measuring sound in water, and also developing methods of calibrating the instrumentation that is used to measure sound in water. For example, hydrophones, which are underwater microphones. So a lot of the drivers for that work come from, if you like, the underwater technology industry. So marine acoustics technology is used for a lot of the kinds of applications that radio waves are used for in air. So you have sonar, which is an analogy to radar for visualization. You have underwater acoustic positioning systems, analogous to GPS systems. You have communication, navigation, mapping the seabed, lots of other applications of sound in water where we utilize sound and acoustic technology to tell us information about the ocean environment. Most recently, there's been a driver to measure sound in the ocean, which comes from environmental concerns, that some of our activities in the ocean generate a lot of noise, unwanted sound. For example, shipping or construction for wind farms or oil and gas platforms and so on, or demolition of those facilities using explosives. And this generates a lot of unwanted sound, and sound is now unwanted noise is classified as a pollutant by international regulation. So the motivation is to measure absolute levels of sound in the ocean, and some of our work is motivated by that and is directed towards those aims. One final subject that we're looking at the moment is deep ocean noise and trends in deep ocean noise. In particular, whether we can tell from those trends anything about climatic variables such as sea surface temperature and Antarctic ice coverage. It turns out that simply by measuring with a hydrophone, an underwater microphone in the deep ocean, it's almost like an acoustic thermometer. You can say things about how the temperature of the ocean's changing and how much the ice is melting, because it makes a sound which you can pick up with the hydrophone. So that's a very exciting current area of research we're into. If I were to introduce someone to acoustics and advise them about a book to look at, I would actually say that the two speakers we had today have both written excellent books. Trevor Cox, Sonic Wonderland is a tremendous introduction to acoustics. And if you're interested in bubble acoustics, Tim Layton really did write the book on the subject with the acoustic bubble. But I would also advocate someone reading a book by Michael Goldsmith, which is called A Very Brief Introduction to Sound, and it's an excellent introduction to the subject for those who are unfamiliar with its concepts.